Hello friends, today we're going to talk about plotting points and graphing using points. This is stuff you've already done before, so it should be pretty easy. First part here is the name of the quadrants. So we start here and then work our way around this way. So this is quadrant 1. We use Roman numerals. Quadrant 1, quadrant 2, quadrant 3, quadrant 4. You can see in quadrant 1, both the x value and the y values are positive. Quadrant 2, the x value is negative, y value is positive. Quadrant 3, x and y are both negative. Quadrant 4, x is positive, y is negative. So it says plot each point and identify the quadrant in which the point is located. So remember, this is quadrant 1, 2, 3, and 4. So this first one, -2, +1. X is -2, y is +1. So starting at the origin, I go left 2, up 1. So that is my point A. And point A is in quadrant 1. Point B, -3, -1. So again, start at the origin. We start in the middle there. Let's make our origin red. Start in the middle. And then I'm going to go, because it's negative, I'll go left 3 and then down 1. That's point B. That's in quadrant 3. 4, -4. I'm going to go right 4 and up, or I'm sorry, down 4. That's point C, and that's in quadrant 4. -4, +4, starting at the origin, I'll go left 4 and then up 4. That's point D, that's in quadrant 2. And then -4, 3/2. If I put 3/2 in my calculator, it'd be 1.5. So that's like -4, 1.5. So I'm going to go left 4 again from the origin and then up 1.5. That's my point E, and that is also in quadrant 2. We'll be dealing a lot with linear equations. It's in the form ax plus by equals c. A and b cannot be 0. C can be 0. A, b, and c are all going to be numbers here, but we'll have the x and the y. That's the standard form. The solution for a linear equation, an ordered pair, which is x comma y, is a solution to the linear equation if the equation is a true statement when the x and y values of the ordered pair are substituted into the equation. So here, our equation is y equals 2x minus 3. And we're going to check it for these different points down here. So first we're going to decide if it fits with the equation, and then we're going to decide if it's actually on the line. So let's look at point A here. X is 0, y is -3. So I'm going to say, is it true that -3 is equal to 2 times 0 minus 3? 2 times 0 minus 3 is -3. So yes, it's true that it's on the line. I'm sorry, yes, it's true that it works for the equation. Let's see if that point is on the line. 0, -3 is right here, and yes, it is on the line. So yes, and yes for this one. Yes, it works for the equation, and yes, it's on the line. Part B, 3, 3. So I'm going to plug 3 in for x and y. So 3 equals 2 times 3 minus 3. Is that true? 2 times 3 is 6. Take away 3 is 3. So yes, it works for the equation. Let's see if it's on the line. That point is right here, and yes, it's on the line. 2, -3. So plug -3 in for y and 2 in for x. See if that's true. Is it true that -3 is equal to 1? No, it is not. Let's see if it's on the line. 2, -3 is right here, so it is not on the line. And then our last one, our x is -1, our y is -5. So is it true that -5 is equal to 2 times -1 minus 3? 2 times -1 is -2. Take away 3 is -5. So yes, it works in the equation. Let's see if it's on the line. 1, -5 is right here, and it is on the line. We're also going to graph some equations by plotting points, so by plugging the numbers in. I'm just going to use -1, 0, and 1. You can use any numbers you want. Those just seem to be the easiest ones that I want to use. So then I plug that in for my x value. 2 times -1 plus 1, because they're telling me here that y is 2 times the x value plus 1. 2 times -1 is -2, plus 1 is -1. So that means there's a point at -1, -1. If I plug in 0, 2 times 0 plus 1 gives me 1. So 0, 1. And then if I plug in 1, 2 times 1 plus 1 is 3. So 1, 3. And then I will just connect those. Oh, that wasn't very good. There we go. Make sure you put arrows. All right, same thing here. Oh, actually, no, we're not going to do that example. All right, so that should be pretty easy for you. Have a good day, friends.